In this class, I will provide you with a high-level theoretical definition of what exactly elasticity is, as well as scalability, and also, we will talk about some AWS services where you can implement elasticity and scalability, which will give us a better understanding of how the two can be used to build resiliency into our architecture. So, let me put in context and give you a global understanding of what elasticity means first of all. So, this is our ID stack. To explain elasticity, I'll take it apart and just keep only the parts of the stack that are relevant. So, you know the physical components are called infrastructure. So, for simplicity, I'm going to represent these three as infrastructure. We eliminate what we don't need for now and we'll keep what we need, in this case, the application. So, in a nutshell, we can say that an application needs an underlying infrastructure to run. The infrastructure consists of clusters of processors, memory, and storage. When a user provisions the application, it is allocated a virtualized set of resources to run. If the application load increases, it can request more resources from the infrastructure pool to meet the demand. The infrastructure pool must be able to do this, that is, provide additional resources when needed. This allows the application to run uninterrupted despite the excess load. It is like stretching a rubber band to expand it. Now, after a while, if the application's load decreases and it no longer needs those extra resources, it should be released back into the infrastructure pool, just like a rubber band that returns to its original shape after being released. When the application is deprovisioned, the infrastructure pool should recover all the resources. If the infrastructure pool is able to do these things, that is, allocate resources to an application, provide extra resources when an application requests them, and recover them when the application no longer needs them, then it is considered an elastic infrastructure. A cloud should always have an elastic infrastructure, and, therefore, elasticity is a fundamental advantage of the cloud. The cloud service provider is responsible for ensuring elasticity in all three service models, that is, infrastructure as a service, platform as a service, and software as a service. Remember that elasticity is an attribute of the infrastructure, and AWS also provides elasticity to the applications running on it. So, always remember that elasticity in the technical sense is stretching or retracting our infrastructure based on our demand, which gives us the ability at times of high traffic to ramp up and create more instances of our application or pivot down for when traffic is lower. And the really nice thing about this is that, from a cost perspective, this allows us to pay as we go, pay for the resources we need, scale down and save some money when we don't need all those resources allocated. When we think of elasticity, we usually think of elasticity being used for a short period of time. So, for hours or even days, this is really good for those companies that have use cases that may have high traffic spikes, like a social network or something like that can spin up more resources when they're needed and spin them down when they're not. Now, let's talk about scalability. To understand scalability, let's assume we have an application running on an elastic infrastructure. You already know how an elastic infrastructure responds to an increase in load. Now, let's shift our focus to see how an application behaves under the same circumstances. So, when a user provisions an application, the elastic infrastructure allocates sufficient resources for its execution. If the application load increases, the application can react in two ways. One is that, to cope with the increased load, the application can increase its instance size and demand a larger set of resources from the elastic infrastructure, sort of like making itself more powerful to sustain the excess demand. This allows users to continue using the application without interruption despite the excess load. So, when an application does this, that is, increase the instance size with the help of increased resources, it is said to scale up. Once the application load decreases, it must reduce the size of that instance and adjust the resource request to the new load. Therefore, when an application does this, that is, reduces the instance size and consumes a smaller set of resources, it is said to scale down. In this case, Since the application scales up and down, we call it vertical scaling, scaling up and down vertically, hence vertical scaling. So, this was the first case. Now let's see what happens in the second case. Here, to keep up with the increasing load, the application increases the number of its instances. Each instance has a similar size and consumes a similar amount of resources, sort of like cloning itself to keep up with the excess demand. When an application does this, it is said to be scaling out. When the application's load decreases, it disables the additional instances and returns to its original form. When an application does this, it is then set to scaling. So, since the application scales in and out, we call this horizontal scaling. Moving in and out horizontally is horizontal scaling. So, if an application can scale vertically or horizontally to adjust to an increase or decrease in demand, it is said to be a scalable application. An application can only be scalable if it is supported by an elastic infrastructure, and it is because of elasticity and scalability that we can build resiliency into our architecture. Now, keep in mind that the customer is responsible for implementing scalability in applications for IaaS and TaaS. But for SaaS, the cloud service provider is responsible for application scalability. And remember that scalability is an attribute of the application, and AWS also enables scalability of the applications running on it. So, with that in mind, and just to wrap up, let's briefly look at how elasticity and scalability can be used in some AWS services, and we'll start by talking about Amazon EC2. So, to get elasticity within EC2, you can configure EC2 auto-scaling to increase or decrease the amount of EC2 instances that are available to the application. You can also configure auto-scaling to use spot instances. From a scalability perspective, you can increase the size of instances so that the instance is larger to have more memory, more compute capacity. For DynamoDB, its elasticity allows us to increase or decrease IOPS based on traffic peaks. From a scalability perspective, DynamoDB has an unlimited amount of storage, so it scales automatically. For RDS, unfortunately, there is no elasticity as such, since RDS cannot scale on demand. However, for scalability reasons, you can increase the instance size or increase the number of instances, which can lead to downtime. For example, an RDS instance of a single availability zone is not available during the scaling operation. However, in a multi-AZ environment, there is minimal downtime during scaling since the standby database is first updated and then failover to the newly sized database occurs. So, while RDS cannot automatically scale in real time, that is, on demand, it does provide mechanisms to adjust capacity based on your application needs. For elasticity with Amazon Aurora, it can automatically scale up and down to meet varying demand on the database. However, from a scalability perspective, you will need to modify the instance type as well as scale horizontally with additional read replicas. So, I hope it has become clear how important elasticity and scalability are to building resiliency into our architecture.